Hello students. In Mathematics Part 1, let us continue with Chapter 7, Statistics. Classification of data. Raw data. When the data is compiled in the same form and order in which it is collected, it is known as raw data. The raw data is made more meaningful by dividing it into different groups or classes. This process is called classification of data or frequency distribution. The raw data is arranged in ascending or descending order. The repeated occurrence of a number is shown by using tally marks. Three columns, namely scores, tally marks, and frequency, are prepared and entries are made in them. The total of all frequencies is denoted by capital N, and the sum of all frequencies is denoted by sigma Fi. Grouped frequency distribution table. When the number of observations is large, preparing a table is time consuming. It becomes difficult to analyze and interpret the data by an ungrouped frequency distribution table. In order to condense the data and save time, we group the scores, which means that we make their classes. Such a table is known as grouped frequency distribution table. There are two methods of preparing a grouped frequency distribution table. The first method is inclusive method, which are discontinuous or discrete classes, and the second is exclusive method, which are continuous classes. Grouped frequency distribution. The basic terms used in statistics. Range of the data. The difference of the highest and the lowest values in the data is called the range of the data. For example, if in the given data the smallest score is 21 and the largest score is 60, then the difference between the two numbers, that is 60 minus 21, is equal to 39, which is the range of the data. Second, class or class interval. When the observations are divided into suitable groups, each of the groups is called a class. Third, class limit. The end values of the classes are called class limits. For example, for a class 6 to 10, the lower class limit is 6 and the upper class limit is 10. Fourth, frequency. The total number of observations in each class is called the frequency of that class. For example, if there are 20 observations in the class 11 to 15, then the frequency of the class 11 to 15 is 20. Fifth, class width or class size or class interval. When continuous classes are given, the difference between the upper class limit and the lower class limit is known as class width. For example, if 5 to 10, 10 to 15, 15 to 20 are the given classes, then the class width of 5 to 10 is 10 minus 5, which is equal to 5. Sixth, class mark. The average of the lower class limit and the upper class limit for a given class is known as class mark. The difference between two consecutive class marks is also the class width or the length of the class or class interval. Class mark is equal to lower class limit plus upper class limit upon 2. For example, the class mark for class 11 to 15 is equal to 11 plus 15 upon 2, which is equal to 26 upon 2, and which is equal to 13. Let us study inclusive method. In inclusive method or discrete or discontinuous class, the lower and the upper class limit and all the scores between them are included in the class. For example, in class 6 to 10, the lower class limit is 6 and the upper class limit is 10, and all the scores between them are included in the class 6 to 10. Hence, such classes are known as inclusive or discontinuous or discrete classes as shown in the given table. The second method is exclusive method, which are continuous classes. For example, if 6, 10, 10.5, 11, 15.5, 19, 20, 12 and 13 are the given observations, by taking classes 6 to 10, 11 to 15, 16 to 20 as observed in the grouped frequency distribution table, that is inclusive method, we cannot include observations such as 10.5 and 15.5 because the numbers 10.5 and 15.5 cannot be included in any of the classes, that is 6 to 10, 11 to 15 or 16 to 20. Hence, in order to include them, we have to change the structure of the classes. Therefore, if we take class intervals as 5 to 10, 10 to 15, 15 to 20, the problem will be solved. The scores 10.5 and 15.5 can be included in the classes 10 to 15 and 15 to 20 respectively. But still a question arises in which interval the score 10 should be included, in 5 to 10 or 10 to 20. To overcome this difficulty, we follow a convention. We will include the score 10 in the class 10 to 15 instead of 5 to 10. That is, the upper class limit of a class should be excluded from the class. When the lower limit is included but the upper limit is excluded, then it is called the exclusive method of classification. Now, taking classes accordingly and as per the convention of exclusion, we can prepare the table as follows. We can observe in the table the classes are continuous, that is 5 to 10, 10 to 15, 15 to 20 and 20 to 25. We must remember that a frequency distribution table are of two types: ungrouped frequency distribution table where the data is less, and grouped frequency distribution table where the data is large, and it is further divided into inclusive method, that is discrete or discontinuous class, and exclusive method, which are continuous classes. Let us solve practice set 7.3. Question 1. For class interval 20 to 25, write the lower class limit and the upper class limit. Solution. The lower class limit is 20 and the upper class limit is 25. Question 2. Find the class mark of the class 35 to 40. Solution. Class mark is equal to lower class limit plus upper class limit upon 2, and that is equal to 35 plus 40 upon 2, which is equal to 75 upon 2, and which is equal to 37.5. Therefore, the class mark of the class 35 to 40 is 37.5. Let us solve question number 3. If class mark is 10 and the class width is 6, then find the class. Solution. Let the upper class limit be x and the lower class limit be y. Class mark is equal to 10, which is given. Using the formula, class mark is equal to lower class limit plus upper class limit upon 2. We get 10 is equal to x plus y upon 2. Therefore, x plus y is equal to 20. Let this be equation 1. Class width is equal to 6. That is given. Therefore, class width is equal to upper class limit minus lower class limit. Therefore, x minus y is equal to 6, which is equation 2. Adding the two equations, equation 1 and equation 2, we get x plus y is equal to 20 plus x minus y is equal to 6. Eliminating y, we get 2x is equal to 26. Therefore, x is equal to 13. Substituting x is equal to 13 in equation 1, that is 13 plus y is equal to 20. Therefore, y is equal to 20 minus 13, and therefore y is equal to 7. Therefore, the required class is 7 to 13. 5. In a tree plantation project of a certain school, there are 45 students of Harith Sena. The record of trees planted by each student is given below. From the given data, prepare a frequency distribution table. We will arrange this data in the ascending order and then prepare a frequency distribution table which will comprise of number of trees, which is the score, tally marks, and the number of students, which is the frequency, which is written as small f. From the arranged data, we write the number of trees planted by students in the first column. We use tally marks to denote the number of students, and we record the number of students in the third column, which is frequency. Therefore, the number of students who planted 3 trees are 10. The number of students who planted 4 trees are 11. The number of students who planted 5 trees is also 11. The number of students who planted 6 trees is 7. And the number of students who planted 7 trees is 6. Therefore, the sum of all frequencies, that is capital N, is equal to 45.